Welcome to the Vulnerable Scientist Podcast, a space for scientists to be honest and authentic on their stories. This is your host, Sarah Nyakeri. Here is the second episode of a new series where we are letting Kenyans give their views on the recent GMO ban being lifted after a cabinet meeting on October 3rd, which was chaired by the Kenyan President William Ruto, who happens to be a scientist with a PhD in ecology. This comes after a 10-year ban by a previous public health minister. After our previous episode, where we had a cancer researcher, Dr. Vic Oria, to give his views, I promised to talk to someone who has made a GMO before so that they can explain to us more about this thing. In this episode, we have Dr. Susan Moenga.
My name is Susan Moenga. I am a postdoctoral research associate at ICRISAT here in Nairobi. I am also a computational biologist for a seed protein company called Nucisa based in California. I have a background in biotechnology. I got my undergraduate training in the Kenyatta University here in Nairobi and my master's degree at Wageningen University, and then moved over to University of California, Davis for my PhD in plant biology. So this is really plant biology, plant biotechnology. That's kind of my area.
Could you explain what GMO is and how it is made?
Well, so I prefer to call them genetically engineered organisms and less genetically modified. And I'll explain in a second why that is. So genetically modified organisms, as we generally like to term them, are living things that have intentionally been artificially modified at the genetic level. And so our characteristics for any living thing, be it a microbe or an animal, a plant, a human being, the characteristic of a living thing is determined by two things. The genetics, which is largely the genome or the DNA, as we like to refer to it, as well as the environment. And so when you artificially modify one of those things, which is the DNA, then you end up with a genetically engineered organism. So the reason why I prefer the engineered rather than modified is because engineered shows intent, and that's the most important part of defining what genetically modified organisms are, rather than modified, because modification can occur without the intent of, say, a person in this case, resulting in an organism that's not genetically the same as it was before.
That's quite interesting. So I guess I'll ask you, is improved kienyeji, grafting, breeding, genetic engineering or genetic modification?
So so improvement. So we've been breeding, we've been improving things around us from as long as human beings have been tinkering with the environment. And one of them, for instance, that we can easily recognize is, as you mentioned, improved chicken, for instance. We've been intentionally, taking a chicken that we like a certain trait about, we take another chicken and, we kind of interfere right there and make sure that they mate. We get eggs, we hatch little chicks that have now maybe a combined set of traits that we really like. Now, while we are tinkering with that process, which is similar to grafting, so perhaps we like the fact that a certain plant is able to take up water really, really well, but then we are not really interested in the product of its above ground biomass. And so what we think is, oh, well, what if I went in and I took advantage of that root system and I put in something, maybe I want oranges. So I take a lemon trunk and I graft an orange on top of it. So I'm utilizing the root or the root system, but then the product at the top is quite different from what originally it was intended. So there's tinkering there, yes, indeed, but it's not happening at the molecular level. So we call this is still within conventional breeding. And so that's slightly different. So that's why modification is a bit of a misnomer in a way, because modification essentially means that, yeah, okay, well, there may be tinkering, you may be intentional, but it's not necessarily being engineered. It's not at the molecular level being engineered, and that really is the distinct difference between conventional breeding versus this molecularly enabled kind of genetic modification.
So the ones that we're talking about right here, the GMOs that were banned, were from the molecular level.
Yes, so the ones that we're addressing today, this is at the molecular level. So the way that we get to this genetically engineered organisms is that we go in, we even without necessarily having figured out the whole expanse or the spectrum of the whole genome, we can go in and insert a piece of DNA whose function perhaps we really very well understand, and that could be because of its source. It could be coming from another plant that has a characteristic we like disease resistance, and we insert that DNA into the target organism, and then hopefully we do get the treat that we're looking for, the treat that we have borrowed from another organism. So that's what we refer to as genetically modified organisms or genetically engineered organisms would be the ones where at the molecular level we've gone in and we inserted a foreign piece of DNA that is not inherent to that particular target.
Is there a danger to pick genes from another, like for example, an animal and putting them into a plant, or from a bacteria and putting them into a plant, or is it safer to to get it from a similar plant to another plant, for example?
Right. So that's a really important question because I think this is where a lot of people struggle with. Is it dangerous? So my, off the bat answer would be, well, no. And part of that is because even in nature, this we call it horizontal gene transfer when there's gene flow happening across organisms that are not close genetically speaking. And so just very quickly, there's a paper that came out recently of scientists that found a whole range of genes, like 50 of them, of plant DNA, plant specific genes or genes that are really distinctly known to be a plant kind or plant type that were found in insects that tend to live on plants or survive on plants. And so nature by itself has allowed for this kinds of processes to occur, and somehow it helps the organisms that are participating in this exchange of genetic material to be even fitter than their counterparts that exist within that environment. So it's difficult to really say, is it dangerous? Because, what is a reference, right? If it's already naturally occurring, and what we're doing is now learning from nature. So we're going in and saying, well, if this is happening already in nature, like some bacteria were already transferring genes. So, for instance, the bacteria that's commonly used as a vector, as a vehicle to move a gene from one plant to another, or a gene from, say, a bacteria or an animal to another organism, this bacteria was already doing this by itself, and this has been known already. And I think that the earliest documentation for this bacteria transferring its DNA into plants, it goes back millennia, right? So what is dangerous exactly? At the molecular level, DNA is non-living, right? So it really it doesn't matter. It's the protein for which that they code for that then we start thinking about. Now, if we're making a protein that would otherwise be toxic to a person, then yes, of course, then that would be quite dangerous. And that, I mean, of course, then we come back to the table as to what's the interest, what's the purpose of that particular experiment of transferring a toxic, or rather, gene that's coding for a toxic protein into a plant. And toxic for whom? For the consumer or not? But DNA itself, whether it's coming from an animal, whether it's coming from bacteria, DNA itself, well, I mean, it's not toxic. It's molecular material. It's all over. It's everywhere, right?
So, have you ever made a GMO?
Yes, I have.
Do you want to talk more about it in brief?
Sure. So in my day-to-day work, in my day-to-day experimentation, and this goes way back, like I mentioned, my background is biotechnology, and so some of the most common experiments you do are really tinkering with these kinds of things. And I say tinkering to show that this is a learning process, not so much that we're just taking liberty with nature and just like messing around and tinkering. So we learn. So for instance, during my master's degree, I studied two different plant systems that they're genetically, they're quite similar, and they're both trees, so they're not really things that we consume as food, but they're very similar on every other aspect. But there's a very important aspect that they distinctly differ, and that's the capacity to to fix nitrogen for themselves. So essentially make food for themselves. So when farmers go to the garden, one of the things that we are always crying about is fertilizer. And a major component of fertilizer is nitrogen or nitrate. And yet there are some plants, in nature that have perfected the art of fixing their own nitrogen. So beans, for example, or legumes are known to do this. Now there's some plants that, while they're really, really similar, at that really important aspect of being able to fix nitrogen, they differed. And we wanted to understand molecularly what is it that makes them different. And part of that understanding is now then that becomes a tool. So, for instance, we know that beans can fix nitrogen, but maize can't. Wouldn't it be wonderful to have maize fix nitrogen? And so one of the, I'd say, my genetically engineered plant that I made while, studying the systems was transferring now the genetic material, various chunks of genetic material from the plant that could fix nitrogen to the other plant that couldn't, even though they were very, very similar in almost every other aspect, right? And then to see whether I'm able to induce that characteristic in the target plant. And so while I'm not, always allowed to talk about all these aspects because there are institutional restrictions, but that I'd say that's one of the first things I worked on without going into further detail.
Thanks for that. What does it mean to you for the GMO ban to be lifted in Kenya as a Kenyan?
Right. I mean, I have to say, really, I'm quite thrilled. I'm stoked beyond measure. One of the things I was so worried about as a young scientist. So when I went to do my master's degree, I started my master's degree in 2012, and that's exactly the time that this moratorium was put in place. That essentially stopped most of the research work in genetic engineering, as well as really growth and commercialization of any genetically engineered produce and product in this country. I mean, I was just that was very disappointing because, as a young scientist, essentially your view of the world is really just like the world is your oyster. You're going to experiment with all the things possible. You're going to query your environment. You're going to build systems that are resilient, that can help your farming community, that can help your innovators come up with really interesting things for whether they're solving problems in nutrition or resilience to climate change, disease resistance for both our livestock and our crops. And then all of a sudden, there was a ban, and I thought, oh, well, this is the end of it. So, like, what does, what opportunities then are there for people like me who are really curious about, molecular biology and the tools, the really fantastic tools that we could get to help us enhance our environment and our food production system. So when this was lifted a couple of days ago, I thought, wow, this is such a gift. This is a gift not just to scientists like myself, but really even just for our children. When they think about the future, and we're constantly talking about tech in the future, but this is really part of tech. I think that it's important that we don't limit the conversation to just food. I think that there are so many other opportunities. Imagine the things that I was describing earlier about, moving DNA from one organism because it has a trait that we like to another. We could be making products for our own consumption or even for export that contain material that naturally they don't. But now once we move that DNA material into the target organisms, it could be bacteria. We could be making bacteria that can degrade plastics around us, right? This would be fantastic, but we couldn't do that with a GMO ban in place. So this is not just for food. We could be making medicines that are just amazing. Right now, when we think about the say the I think there's a lot of interest in naturally produced or naturally sourced medicinals or medicinal plants, and often the drug or the limitation is that they're compounded by so many other potentially toxic compounds, and so it's very difficult to know what's the bioactive compound. And genetic modification can be really a very easy way to kind of just remove all that noise and target on what's the most important thing. And if we don't want to grow it in a plant that's cumbersome to grow, right? We can do it in an annual that takes 3-4 months to grow, and boom, we've got our medication. So I think that it's very exciting both to the research community. It's very exciting to, innovators. It's very, very exciting for our markets. Now we can open our markets as well. You know, we're not just limited to, oh, we can only export organic material because that's the only stuff that we grow. We can now be exporting to, to markets that are ready for genetically engineered foods as well. So I'd say I really am quite super, super stoked that this ban has been lifted.
What message do you have to an anti-GMO?
I, I've listened to several arguments, and this is like for years, right? Because you've got to learn this, and I think that at the beginning, when you're beginning to learn about genetic modification or engineering, it can be a very scary aspect, especially when it has to do with things that are very core to the human existence, like food and our food systems. So I understand the fear. I understand the fear very much. And some of the arguments or some of the talking points that you hear quite often are actually away from the science itself. So they're about the social dynamics. So once you understand, like, our local government, how sure are we that we're going to be safe, and that safety includes our own farming systems. How safe are they going to be from these foreign conglomerates that could essentially come and wipe out our variety of seeds that are available to farmers? And those are legitimate concerns, but those are policy questions, and those are not scientific questions. And I think that a lot of people are mistakenly conflating those two things. So I understand concerns that have to do with the environment, the ecosystem. What if this, we develop, for instance, a corn seed that's just superb. It has great yield. It grows really fast. It is disease resistant. There's no such thing as fall armyworm because it's, pest resistant, and all the wonderful things that you can envision in your maize plant. But then, if we develop something like this, essentially every farmer would want it. I can't imagine a farmer who wouldn't want it. And then progressively, what happens over time is that, there's just very little genetic diversity within our, maize collection. And there will be other challenges. Pests are also very smart. They're constantly evolving. And so, one day you'll have a huge, new disease that then wipes out everything because every farmer is growing the exact same thing. So those are really legitimate concerns. And I think that these are very useful conversations to have, but I think it's important to separate those concerns from, are we worried about the technology? And if I'm worried about the technology, is it because I don't understand the technology? And if that's the case, where do I get the information? Well, am I worried about the implementation and perhaps the impact it will have on the environment and our biodiversity? And if that's the case, what kind of steps do we need to take as a country, and how do we protect our own biodiversity? What are the entities that are, tasked with ensuring that, regardless of what's being developed, we at minimum are keeping, we have this in situ collections, or we have the seed collections that ensure that, we still have that biodiversity that's represented. Is it a policy question? Are we worried about, the big ag coming and completely taking over our seed supply systems? And what does that, what is it that could be done? And what are the entities that are tasked to protect both the farmer and the businessman within the whole value chain that depend on the seed systems and the seed supply chain for their livelihood? And I think generally we need to separate those questions. I understand some of these concerns, and I think that we need to have those conversations separately. So I'll say that your concern to an anti-GM person, your concerns are often, they're quite legitimate, but I think that perhaps you need to direct them to the right people or to the right agencies for your concerns to be either listened to and addressed.
Is there anything else that you'd like to add?
Yeah, I think I'd say that I think most people are quite afraid of things that they don't understand. Even I am often quite afraid of things that I don't understand. And this can range from, things in engineering to technology to when I hear things about, astrophysics and the space and quantum energy, I think, oh my God, are we going to crash? Are we going to, like I understand that new things and things that we don't have a deep understanding of can be quite scary. But fear has never really it may slow down the progress of something, but has never really stopped advancements, especially in the technological world. So my suggestion to folks that are, they feel fearful about, genetic engineering because they feel like, oh, our food systems are now no longer under our control, to embrace the opportunity to learn, not so much embrace genetically engineered foods or organisms or just the technology overall, but to embrace the opportunity to learn. And we can only together as a society be better, from this. If we decide collectively that this is not, it's not worth the risk, right? We take the step of what we call the precautionary principle. This is not just worth the risk. Then okay, then we explore what other opportunities there are for this. Is not a this is not a zero sum. We can, there are so many other opportunities, just that this is one of the tools, and an exciting tool nonetheless.
Have you ever eaten a GMO yourself?
Oh, severally. Oh my goodness. I lived abroad for so many years, and I intentionally, out of principle, refused to buy organic foods because I just think that the niche is based on misinformation and not really on science. Obviously, I'm a scientist and I'm a big fan of all things science, and so I loved everything that, I mean, like, if I think, oh, there's so many people over the last 20 years who've put in hard work to develop a tomato that can stay on the shelf for 4 weeks, I'm gonna eat that tomato. Absolutely. I've eaten so many genetically modified foods I couldn't begin to count.
That's Susan for you. Do you have a question, comment about what she just said? Tag us on social media at TV Scientist Pod or The Vulnerable Scientist. In the following episodes, you will hear voices from typical scientists, Kenyans, farmers, and even someone who has been a GMO regulator for a very long period of time here in Kenya. Stick with us to hear from those people. To support or learn more about this show, go to thevulnerablescientist.com and you can see how you can be part of us. Till next time, goodbye.